Okay, I think we're back on board here. Don't worry, we're not actually starting over. Okay, so again, we want to talk about the direction, the strength, the form, and are there any outliers? All right, so we said direction was positive. Let's get back on there, sorry. Thank you. Blue wheel death bummer, for real. It's a huge bummer. Again, so if you're looking at the scatter plot, you can definitely see there's sort of a increasing trend, right? So as the city miles per gallon get higher, the highway miles per gallon also get higher. I'm not going to try to go back in my slides in case it blows up again. So very good. Whoever said positive, that's exactly right. How about the strength? What would you guys say for the strength of this relationship? Again, it's kind of a subjective thing. Strong, weak. What would you say? Medium, maybe? Say moderate? Yeah, okay. So again, I'm going to try to go back here. So if we're looking at this and we're trying to think about the strength, it's maybe a little hard to say because we have some weird points in here, right? So if you take out this point and if you take out these points, we have a very sort of strong trend happening there, right? And I would even say, keeping all these points in mind, we do have sort of a very, it's kind of very tightly clustered around a line there. So I would actually say this is a very strong association. Again, if you look at certain parts of it, it's even more strong. So again, because it is sort of tightly clustered around a line there, that's kind of what we're looking for. Is it spread out around that line, or is it really tightly clustered? So if you said moderate, I see where you're coming from, but I think this is actually a pretty strong, strength. Yeah. What do you guys think for form? Do we have something linear or something nonlinear? Linear, yeah, definitely. It's not going to be perfectly linear, but that is definitely a linear relationship. And what do you guys think? Do I have any outliers going on in that plot? Yes, absolutely, right? So if nothing else, this point out here is definitely an outlier, right? That's way far away from all the other points. So both its city mile per gallon is really big compared to the other ones, and its highway mile per gallon is also really big. So that would be a point that's an outlier in both directions. If you wanted to make an argument that some of these points here are maybe somewhat outliers, I would buy that. But there are definitely outliers happening in this plot. So yes, we have there's at least one. And going back to the back channel comments earlier, what kind of a car gets 105 miles per gallon? Well, that's actually the Nissan Leaf, so that's an electric car. So it's cheating a little bit if you were wondering what that is, and that was the Nissan Leaf. So that's how it gets such a high miles per gallon. Okay, so that's our little summary of each thing. Let's quickly put that into a sentence form. So we can say that we see a strong, positive, and linear relationship between city MPG and the highway MPG. There's at least one outlier in the data set. So again, just kind of summarizing what we just said. It's always better to put things into sentence form like that. And then you don't have to say what the outlier is, but I'm telling you just for because we know what that is, I can tell you what that is. So again, we see a strong positive linear relationship between city miles per gallon and highway miles per gallon, and there's at least one outlier happening in this data set. Any questions you guys can think of on describing scatter plots here? Yeah. Okay, so if we have sort of a cluster of points, so maybe going back to like this plot up here, for example, like what if we had a point like way out here or something like that? You could still talk about that as being an outlier. So even though in those two relationships there's not really two variables, there's not really a relationship. So you could say there's not really a positive or a negative association there. It's very very weak. There's almost no relationship. Linear, well, who knows? It's not really just kind of a blob. You could still say that yeah, there is that one point out there maybe that's sort of different than the rest of the values. So yeah, you could still talk about outliers even if you don't really have anything going on. Okay, great. Well, again, we've mentioned this already a little bit, but so thinking about strength so far, we just kind of said weak, moderate, strong. Again, we do have a numerical way of measuring this association. It's something called correlation, which is this little, we'll use our little r, lowercase r there to represent correlation. And by definition, it measures the direction and strength of a linear relationship between two quantitative variables. So again, of course, we're talking about numerical variables here. The correlation will measure the strength and direction of a linear relationship in those variables. So the formula we have here is maybe looks sort of like something you've seen before, kind of almost like the standard deviation going on here, where we're taking deviations and multiplying them together, all these things. We're never going to ask you to calculate this by hand. We're just going to be using technology to find what the correlation is. That would take a long time. But here's the formula if you are interested in knowing what it is. And then on the far right, I've put a different representation. I've used zx and zy there, and that's just to denote that this is kind of like, for the x here, this is kind of like a z-score, right? So I'm taking my values, I'm subtracting off the mean. So I'm taking a value and subtracting off the mean, subtracting off x bar and dividing by the standard deviation. Exactly what we were doing before. So again, you don't need to really worry about that representation, but that's kind of what I mean by this z sub x and z sub y over on the right side there. So again, we're not going to do this by hand, but there are some important facts and characteristics we want to talk about for correlation. So first point to note about correlation is that it does not distinguish between explanatory and response variables. So why might that be? Well, if we look back here again, kind of our general notation that x is our explanatory variable, y is our response variable. If I switch those things around, so if I change which one I'm calling my response variable and which one I'm calling my explanatory variable, if I switch those around, the formula is still the same, right? I'm not the correlation is not going to be any different based on which one I choose. So again, the point here is that the order does not matter. In the formula for the correlation. All right, next sort of important fact here is that the correlation R does not change when we change the units of the measurements of x, y, or both. And why is this? So this kind of goes back to the fact that in that formula, we sort of have a z-score going on. We sort of have a z sub x times a z sub y. And so if I'm standardizing my variables, it doesn't matter what units I have them in. The correlation will be the same. So this is the case because in the formula we standardize standardize the variables. So if I'm looking at the correlation between height and GPA, doesn't matter if I'm looking at your height in inches, your height in feet, your height in meters, whatever that is, the correlation will be the same between those two numbers. And if you think about it, that should make sense, right? The correlation is sort of talking about a relationship. The relationship doesn't get stronger or weaker if you change what units you're in. So that's, again, kind of something you would hope to be the case. But just that's kind of the idea there. All right, third point here is that positive correlation indicates positive association. Negative correlation indicates negative association. That probably goes without saying. If the correlation is positive, that means you have a positive relationship. If it's negative, you have a negative relationship. Won't spend any more time on that. And then the correlation is always between -1 and +1. So if I can kind of make the little continuum here, if this is my correlation from -1 up to +1, maybe right here in the middle is 0. Down here at -1, I have a perfect negative relationship. Up here at +1, I have a perfect positive relationship. And here in the middle, I have no linear relationship. And then you can imagine there's sort of a continuum in between there. So as I go from 0 down to -1, the relationship becomes negative and gets stronger and stronger, but in a negative direction. As I go from 0 up to +1, I'm going from no linear relationship to now it becomes positive, and then it gets stronger and stronger and positive. So kind of keep the continuum there in mind. But point is, the correlation is always between -1 and +1. That's the important thing there. And then just sort of as follow-up, again, the point is that correlation can be +1 or -1 exactly, but that will almost never be the case, unless you have some sort of a artificial situation going on, such as this one. So in this example, suppose the two variables that I have here are maybe kind of hard to see, but this says hours, and this says the pre-tax wages. So if I think about the number of hours I work, how that relates to the amount of money that I make, if I'm making $12 an hour. So if you told me that you worked 6 hours, I know exactly how much money you made. If you told me you worked 3 hours, I could tell you exactly how much money you made. So we have this perfect relationship going on here. So what is the correlation for this example? Anybody? This perfect relationship? Yeah, exactly. It's here R equals 1 because it's this. We have a perfect relationship, and we could even write down here exactly, right, that y equals 12 times x, right? So however many hours you worked, multiply that by 12, you know how much money you made. So correlation is 1 because we have this perfect relationship going on here. So it can happen. The point is that it can happen, but it's not very interesting when the correlation is exactly 1 or -1. And then just note that to actually look at a scatter plot and exactly say what R is really tricky to do. So I won't ask you to do that. If we're just looking at a scatter plot, all I'm interested in knowing is the relationship sort of strong, moderate, or is there sort of weak or no relationship there? And then in your notes, I put a website if you'd like to practice guessing what R is. There's a little applet there. You can give that a try. A few more facts to talk about correlation, and then we'll look at one more example before we finish up here today. And this is something that this is actually a really important one. I think a lot of times we talk about correlation for things that doesn't really apply to. So again, what we're talking about here in a scatter plot is two quantitative variables, right? So we have both of these are numerical variables, and so if we have variables that are not quantitative, then correlation is meaningless. You wouldn't talk about correlation in that situation. So so it would be incorrect to talk about a correlation between hair color and ethnicity, or something like your class rank, freshman, sophomore, junior, senior, and your GPA. But that doesn't mean there's not a relationship between those two things. Absolutely, that's not what I'm saying. Just to say that we wouldn't call it correlation. We would talk about an association or a relationship or something like that. So just remember that, and if you think about it, correlation, we have to calculate it. It's a numerical thing, so we have to have numerical variables. Keep that in mind. Another very important thing here is that correlation only measures a linear relationship between two variables. So correlation has no way of describing if there's some other relationship going on here. So in this example, we have a scatter plot, quote unquote scatter plot of down here on the x-axis I have just the x value, and then over here I have x squared. So this is x and x squared. So again, a perfect relationship, right? If you tell me what x is, I can tell you exactly what x squared is. If you tell me what the so there's a perfect relationship going on here, and yet if you punch these values into a software, you would find that the correlation is equal to 0. It says that by the correlation, it says that there is no relationship between these two things. And again, here you can very clearly see that when I say all that means is that there's no linear relationship between these two variables. So just keep in mind that correlation only talks about a linear relationship. That's very, very important. So when the correlation is very small or 0, doesn't always mean that there's no relationship. It could still be something like this happening, but it's just not a linear relationship. And sort of like the mean and standard deviation, correlation is not a very resistant measure. So it is strongly affected by outlying observations or sort of unusual values have a big impact on the correlation. So we'll look at an example of this final one. But any questions on the sort of these facts or characteristics of correlation? Okay, well let's take a look at another example here to kind of illustrate this last point. So again, in your notes, you actually have the data sets. I haven't put that on my slides here. But the example that we have here now are, again, we're going to go back to some movies. You guys all like movies. I know I do. So the data that I have here are the top 20 directors. So people directing movies. The variables that I have on them are the number of movies that they've directed and the total gross in millions of dollars that they have they've received from their movies. So again, commenting on the scatter plots and the correlation. And I guess, so let's just focus on so I guess the other note that I made in the notes here is that let's first talk about this one that has all 20 of our directors in that scatter plot. So what do you guys think? What's the strength? Again, we're talking about the strength, direction, the form. So maybe starting with the direction. Can anyone see a positive or a negative direction in this plot? It's a little bit hard to say, right? Looking at the plot on the left here. So this would probably be kind of a weak scatter plot. We don't really see maybe we don't see a very strong relationship going on there. Direction. Can anyone pick out a direction there? Is it sort of a positive or negative thing? Again, hard to say, right? Yeah. Looks like it might be slightly positive. Yeah, okay. So we might have sort of, if we take all the data points in, we might have something like that going on. Think about a very wide thing there. It is sort of going up anyway there. So yeah, so I'll say maybe it's positive. Put a question mark there though. That's maybe hard to say. What about the form? Do we have something linear going on here, something nonlinear? A little louder. Anybody? Nonlinear? Okay, so we might have something that's kind of nonlinear happening here. And do you see any outliers on that plot? Definitely, right? Yeah, so yes. And if not, maybe this point down here, but definitely this point up here is an outlier. And if you actually have the data set there, you can see that that corresponds to Steven Spielberg. Make sure I spell his name right, or he'll come find me, right? All right, so we definitely have an outlier going on here. So let's, assuming that that is an outlier, we can remove Steven Spielberg, so no Spielberg here. And if we kind of think about the same things, the strength, what do you guys think for the strength for now the plot on the right? Strong, weak, moderate. Again, it's very weak, right? So we have very weak relationship. Is there a direction now in here? It'd be hard to pick out a direction, right? So again, we'll put maybe nothing. So if there's no directions, linear, nonlinear, well, again, who knows? Outliers, again, it's looking less like there's an outlier, right? There's so I would over here I would say in this plot there's not really any outliers. But I guess the point here is that if you remove an outlier, a scatter plot can look very different, right? And this will be reflected in the correlation. So in your notes there, I've included the summary statistics. So you can, again, using JUMP, you can get to the correlation. We'll look at that in recitation, how exactly to do that. So this one here is with Spielberg, and this one is without. And the interesting thing to note here is that the correlation up here with Spielberg is positive, right? 0.39, almost 0.4. And so when we were looking at this one here and we said it was positive with a question mark, well, it must be positive. The correlation is positive. So we do have something going on here maybe. But again, the point here that we're trying to illustrate is that the correlation is heavily influenced by outliers. So when I remove that outlying point, Spielberg is pretty clearly an outlier. The correlation drops down to 0.05, so very close to 0, indicating that there's not really any sort of no linear relationship going on in that plot. And again, that's very visible. It's not really any relationship of any kind. It's kind of a blob of points up there. You don't really have a clear way to say how these variables relate to each other. Any questions you guys can think of on this example? Oh yeah, okay. So what is the significant probability? There's a lot of things on these output that we won't really talk about. You probably noticed that in when you've been using JUMP before. I actually don't know what that is. That's I'm sure there's probably some test for if the correlation is significant or something like that. So I don't know exactly what they're doing there for JUMP within JUMP. So again, you can sort of just ignore these things. It does give us the other summary statistics here. That gives us the mean and the standard deviations. So if you needed that information, there it is in one snapshot. Okay. And just a final notes here to finish things up. That correlation is not a complete summary. So again, kind of as indicated on this little technology output here, when you're describing two variables, kind of looking at the relationship between them, again, it's good to know what the correlation is. That's very important, but it's not the whole story, right? We would also want to maybe think about what the mean of those variables are individually, or the standard deviations. So it's good to report more than just the correlation when you're talking about two variables. Other question you guys can think of for anything on correlation or interpreting scatter plots? Again, you'll get some good practice on interpreting scatter plots and recitation next week. So we'll hold on till there, I guess. All right. Well, I think that brings me to the end of the notes. I'll let you guys out of here. Thanks so much for being here, and have a wonderful weekend. We'll see you guys next week.